Okay, so let's go ahead and jump in on our part one today and take a look at this particular project where we're going to convert a local survey to GNS. And I'm just going to walk you down through these pieces. We've got about a half hour left here, and let's see how far we can get. So here's a project that we did in 2017. Grandpa and Grandma owned quite a bit of property with a river view, and the parents live right above this a lot here, but this is one of the grandkids. They've got one of the lots here, and they asked me to come out and do their preliminary work. So I did a site survey, topo survey, did the research, made sure we recovered the monuments for the boundary, and that's been going through city planning. They hired an architect to design a house for them, and they're working with one of the builders that I've worked with forever, Ken Carter. And Caitlin called and said, I'm ready to build. Ken would like you to stake out the foundation. So I got a hold of Ken and did that. But I wanted to do that with this new solution that we've got with Traverse PC and the Emlet. So I'm going to stake that out with the Oregon N-Trip network. Now, what did I get from Ken? So here's the site plan we turned in. Ken sent me this foundation, and I put it in a plot like this. And I just want to walk you through kind of what that looks like and how this works. So Ken still works with PDFs for the most part. So I can certainly get a CAD file from a lot of the contractors I work with, but Ken is still, even though he does everything in CAD, pretty much just submits plans like this to me. So I've got all the dimensions here, and I took a look at the elevations and stuff just to kind of see what they were putting together. So here's the southern elevation. This is what's going to face the river. This is the northern elevation up here. So they're going to drive down in front of the house, turn into the garage, and then look through the house to the river back there. So I kind of have some idea of what they're going to do here with this. So the first thing I'm going to do is come into Traverse PC, and it's going to take me just a couple minutes to get this foundation outside of the foundation edge put into Traverse PC, because that's what he's going to want me to stake. And I'm going to make some decisions about staking the north side of this retaining wall, but probably, if he wants it, making sure I've got this point on the south end so he can tie that with the foundation down here. And Ken and I have worked together for a long time, so it's pretty easy for me to kind of know what he wants. He was missing a couple of measurements, so I had to have him send those to me. But it was real interesting. I actually sent him a PDF of this, and just circled the ones I needed. And it was real easy then for him to say, oh yeah, I forgot to give you that one, or I forgot to add that one to the plan. He just changed his plan to include all the dimensions that I needed to get around this traverse. Okay, so let's take a look at the first thing I did was start the foundation. Ken's plans call for a 5-foot offset. Okay, well, that's not going to work. He's going to need a little bit more than that, because he's got a few things sticking out of the side of this house here. And so I just called him up and said, Ken, how about I give you a 5.5 foot here? You're still going to end up with 9 feet on the west side over here. And we just had a little conversation about it. He was good to go. So I said, let's come down, and there's lots of ways to do this, and you certainly have got ways that you can come up with. But the plans call for a 40-foot offset from the north property line up here, and I wanted a 5.5 foot offset over here. So I just came up and said, let's do a COGO distance offset. Okay, I'm going to pick this line right here. So I'm at south 52 seconds east from 1 and 2, and I'm going to go 40 feet, and I want an offset heading south right 5.5 feet. And I just created my first point, okay, and I called it F1 and put that in the foundation traverse. So now I had my foundation traverse started. And now I'm just going to walk down the dimensions on his plans, I'm going to use a bearing between F1 and F2 of 1 to 2. So in the bearing, I just typed 1 dot dot 2, and it recalled that inverse for me. Then I'm doing everything with deflection angles. So plus 90 for a right, minus 90 for a left, or sometimes I'll have plans with 45s in them or 22.5s. It's easy for me just to put that angle in, and I just go left, right, all the way around here. Now, his plans are in feet and inches, right? So if I zoom in here, it's 4 foot 2 inches, 19 feet, 5 inches. How do I do that in Traverse PC? Well, I just go to the help topics, the one we were just working with a minute ago, and I just search for entering data or inches. Let's come in and search inches. Let's look at entering data, and right here it tells me I can enter feet and inches. Enter 10 feet, 8 and 13/16 inches as 10F, 8I, 13. Or use lowercase f and I, or use a single quote and double quotes. So 10 apostrophe 8 quotes 13. Traverse PC converts that to decimal feet, okay? So that 10, 8, 13 is redisplayed as 10.73, or more decimals if you include them. So it's really fast for me to run around and put that foundation in. And of course, I'm doing that on this drawing. So as I enter the foundation, I'm seeing it drawn. And it's kind of interesting. When I was all done putting this in, I'll show you this in a minute, I just inserted his drawing right underneath it, converted that PDF to a PNG, and calibrated it to my foundation. And then it made it real easy for me to communicate with him. But of course, before I'm done with this, I went into the closure view and said, I want to make sure that my linear error is 0. That's just the quickest way for me to identify that I didn't make some mistake or Ken didn't make some mistake. So I'm checking his work and checking my work at the same time. And that allows me to get that foundation in. Now, I do want to show you really quickly that I did create a layer for plans. And we include a background layer and layers for crow's feet, all that kind of stuff. I just went into the layers and said, okay, I want to add a plans layer, and just added it. Then I put that picture on that layer. So now I can come in real quickly, turn that on or off. If I have more than one thing on there, I can turn everything off. And it just makes it real easy. And remember now, I'm putting that picture back there because it makes communicating with the contractor a lot easier. I needed 2 additional measurements he didn't give me. And then, of course, when it's all done, I send this back to him, and I just change the color to gray on the hubs I didn't set. So now he knows every hub that I set. I've got a stakeout there with the number on them, and he can hand this printout to his forms crew, and they can go out and start setting the forms on that. Okay, so just wanted you to kind of see how that works with the layers. Now, let's drop out to the field now and talk about what we did to make that work. And to do that, I'm going to create a new project. I'm going to call this May Webinar Part 1. And I won't put anything else in here, but I'm going to check or select a coordinate system. MLIT allows me to come in and use coordinate systems out of a library. So I've come down and chosen the Oregon NAD 83 South, just because I know a lot of you are familiar with that. But if I wanted to, I could use a low distortion zone. I would use the coast one here. So I could use the Oregon coast zone, and that's a low distortion zone. And I'm not going to go into that today, but these are all available in Traverse PC as well. And so I could simply have Traverse PC use this same CRS. And in fact, we're going to do that today. And then elevation is going to be controlled by ellipsoid height. So let's go ahead and apply that. Or before we do, here, one more thing. I'm going to change to feet instead of meters, because I'm working in feet. Okay, so let's go ahead and import. I'm going to import back in the points that I collected to do the calibration with. Probably the easiest way for me to show this to you. So on 3/7/23, I collected those points and brought them in to do the calibration. And let's just import those here so we can kind of get back to where I was out there in the field. Okay, so does this look familiar? Here's Vine Street. Here are 1, 2, 3, 4, 5 monuments that I was able to pick up with the GNSS. And let's just come in and take a look at these. Now, I called this 1001, but it equals my survey point 1. That's a PK in the northeast here. Here's my local coordinates in NAD 83. There's the geodetic position for that, what they call global coordinates. And remember I said that I'm looking for centimeter accuracy. And the centimeter accuracy is 3/100ths of a foot. So these are my RMS values. And they call them standard deviations, and they pretty much are. We can kind of think of them that way. But here's my centimeter, northing and easting, and my vertical a little bit more, but not bad at all. 0.102, I said equals 2. That's a yellow plastic cap with a Wolford number on it, 2602. 105 was actually a cap Bob Manseth had set quite a number of years back. His LS number is 896 when he got grandfathered in. 103 is an iron pipe that was disturbed, so we can include that or not include that in our solution. And then there's another Wolford cap that I tied up here. So I've got everything I need now to come in and do my calibration. Let's go ahead and do that then now, and just kind of see how this works inside of Traverse BC. And remember, I did this in a laptop out in the field, but I'm looking at the points in my office as they were collected, so I could simply come in and export those now, do the calibration, and put those foundation points right back in here like we're going to do in a minute. So that person out in the field could do all of this. Pretty neat here. So let's come back to Traverse BC now. And let's tell Traverse BC that we want to import. Well, here, first of all, let's go into the survey information. We want to set our coordinate reference system to NAD 83. And then let's select a geoid, because remember we told the GNSS project that we were going to use a geoid for the elliptical heights. So that's how it's going to convert from the ellipsoid height with that geoid to mean sea level elevation. So let's come over here and import. We're going to tell Traverse BC we want to bring in an EMLID CSV file. We're going to browse to that same folder we were at. And let's just take a look at some settings here real quick. These CSV files use a header, and look at all the columns in that header. Now there's no way that you're going to type all these in and get it right. I mean, there's just a lot of information that we get out of there. So one of the new features in Release 1 coming out is the ability to get the format from the header, and we can overwrite that format. If you don't quite get what you want, you can put your own in, and you can skip the header line in the file and use what you typed in. There are some options for how to interpret the degrees in there. And then this is important for GNSS kind of work. I can tell it which of the solutions I want to bring in. Now, everything I'm going to bring in today is an RTK fixed point, so I'll filter on those, but I have some other filter options if I want. And let's go ahead and I want to make sure our message view is clear here. Let's go ahead and do the import. So Traverse BC brought in those 5 points for us, created a traverse with those points, okay? But I want you to just take a look at the details here real quick. So here's point number 1. Here's our equals 1 PK northeast. Right away, you're interested in having documentation on stuff like this. Here's my root mean squared. This is my accuracy. So I'm at 3/100ths, 3/100ths, 46/100ths on the elevation. Here's my sample size. I just did a single observation for these. And then here's the base in the N-trip network that that information was, correction was pulled from. And it's 0.87 miles away. So I'm really close to that, and I knew I was close. So here's all those points that are brought in. Now, real interesting, if I were to go to the drawing of just the foundation and tell Traverse PC that I want to plot that GNSS with the foundation. Remember, this is at 5,000, 5,000. The points I just gathered were on state plane. What am I going to have? I'm going to have a couple of dots across here, right? Because I've got two different coordinate systems I'm dealing with, and that just doesn't work. So what I need to do instead is calibrate these. And let's take a look at what we've got in here in this traverse. I'm going to tell Traverse PC to use a 3D GPS. And let's take a look at the points in here. Okay, the reason I set up the equals 1, equals 2, equals 5 like this is because it makes it real easy for me to create the calibration I want. Let's go to calibration, create a calibration, and let's tell Traverse PC that we want to create a calibration out of a particular traverse. We want that one we just imported. We're delineating points in the description with an equal sign. And then this is new. We want to reverse how that calibration is created. Without this reversal, we're going to select a traverse of uncalibrated points with the calibrated points in the description. We want to reverse that. Our calibrated points now are in the traverse, and our uncalibrated points are in the description, because that's what we've got here. We want to calibrate 1, 2, 3, 5 to our GNSS position. So let's go ahead and choose OK. Traverse PC creates that calibration for us, and we can come in real quick and say, is this kind of what we expected? So I see here that I've got very little rotation. Scale is not much different, which I expected as well. And then I've got this huge translation in the X and Y. Here are the points that I used to create that. Here's my 1 and 101. 0.2 being calibrated up to 102. So I'm ready to just say, yeah, this is good. So let's come in and let's call this our May webinar, local to GNSS. And we're going to tell Traverse PC that I'm starting with a local site, that's where I'm coming from, and I'm translating to this NED 83 Oregon South. Let's go ahead and save that, and I'll overwrite the one we created earlier. Okay, so we could now, if we wanted to, come in and calibrate from the GNSS to our survey. So I could say, let's calibrate this traverse. Let's calibrate the entire traverse using this calibration, but let's reverse it. Okay. So now what happens? Let's go ahead and tag that traverse. And look, here's my 102. Here's my 101. Now at 5,000, 5,000, right? Here's my 1106. We're going to take a look at that in part 2. For right now, let's undo that, put them back where they would be normally, and let's instead tell Traverse PC that I want to calibrate the entire survey using this calibration, which is going to move my entire survey up to the GNSS position. So now let's calibrate that. And the details are giving us everything that's being moved. So the point positions are being moved, all the lines. One of the new things in this release is that we can also do raw data and drawings. And this is really, really important. So let me just reiterate again that this was the workflow we were after. workflow we were after said, I want to move everything in this survey to the position used by my GNSS. So I can come in here now and say, okay, what actually happened? Well, here's my calibration information. And I moved everything up from local, uncalibrated, to the state plane calibrated. I did that for the points, for the drawings, for the raw data, and all that's here in the message view, so I know exactly where I'm at. Now, this is going to be kind of fun. I should be able to come in. Let's zoom in so we can see these control points a little bit. See where my 101 is now and my 102? So just like when we had calibrated the GNS to our local survey, we've now calibrated the local survey to our GNSS. Everything's at state plane, but it also matches up exactly like we wanted to. Now, the next thing I'm going to do, and I do this right out there in the field, is I say, I've got a report I can use, the stakeout report, and I can say, I want to look at this particular traverse, and I want to create a report that says, compare 101 to 1. So I'm creating that relationship by saying, look at the points that have an equal in the description. Let's go ahead and generate that report. And now I've got a stakeout report, okay? And I can take a look at point 1, and I'm expecting those differences to be centimeter, right? So here's 0.300, or 300ths of a foot, less than 300ths, okay, linear 400ths. Remember I said 3 was the one, that was the iron pipe that was disturbed. I'll go back and check that. So it's out a little farther. But point 2, which was a Wolford cap, it's about that same error, linear error. And 5, which was a Wolford, is about that same linear error. So I'm probably going to end up keeping point 3 because it's in line with that. I could, however, go back, modify the calibration to not include any of these points, recalibrate, and apply that. Okay, so I just want you to see that I've now moved the survey up to the GNSS position. Okay, so now I can either have someone in the office do this, or I can do this in the field. It really doesn't matter. But I'm going to tell Traverse PC, I want to take these foundation points and I want to export those over back to the MLID. So I'm not going to send the entire survey. I'm just going to send a foundation traverse. Interestingly enough, the MLID wants the coordinates, not the geodetic positions. We're still kind of looking at what the options are there. But remember, the coordinates are now in the same coordinate reference system that the MLID is using. So we should be fine there. And let's tell Traverse PC we want to go ahead and write those out. So here's our stakeout. Here's foundation with header. Now this is important. Remember I said we're doing a lot of work with the headers in here. So we're going to include that header information automatically. So we've got columns labeled appropriately for the MLID. And let's go ahead and export that then. Okay, those 19 foundation points are out. Let's go back to our project now, MLID project, and let's import. And I'm going to import CSV again. Remember, that's that whole alphanumeric thing. And let's bring in the stakeout folder points, foundation with header. So as fast as this can all happen over a hotspot or your internet in the office, I now have brought those foundation points in, calibrated to the readings I would get with the GNSS in the field. So I'm all ready to stake these out now. Now when I'm done staking them out, I'll go in and actually measure those, import them back into Traverse PC just like I did, and I'll run a stakeout report on those just like I did on my control points, because I want to see how close I was on all of those. Okay, so I want to just head back real quickly to our help topic here, and I want to take a look at kind of what we did here real quickly. In our using GNSS, we took a look at this sort of simple solution, and we said, let's tackle this workflow where we want to stake out a foundation on a project that we had on local grid, and we actually moved that entire project up to state plane, the same coordinate reference system we were using with GNSS. We can do that in the field, or we can have someone do the calibration in the office, but it basically means we don't have to make a trip back to the office to do it. Now, a lot of you can pay a lot of money and have the capability of doing that calibration on your controller. I am talking with Emlid right now, and they do have some basic transformation stuff, which is just a translation. But we're going to see if we can't get them to accept that calibration from Traverse BC and do that right inside of Emlid Flow. We'll know here in a little bit. So I want you to come back for the next webinar, and we'll take a look at that project that was the sightline on the lakefront property. And then we'll do a third webinar, and we'll come back and take a look at these individual pieces in greater detail. And I think about that time the next release will come out, and you'll be able to do all of this in TPC 2023 R1.